We could, at this point, spend many more hours looking at the theoretical aspects of network size and operation before discussing practical learning algorithms. But this course is supposed to be a practical one, so let's just skip this for the time being and get some real useful networks working. I would advise that you start small, perhaps by coding some of the simple, for example, 2x2 pixel examples which were shown in the previous videos. Once you've tried this successfully and ironed out all the problems, then it's time to move upwards to more complex networks. The algorithm I'm going to cover in the next few videos is back propagation, which you might remember is the most popular learning algorithm. But first, we must set up a suitable network for the problem at hand. The structure of this is shown on a diagram on the screen. The number of inputs is defined by the problem which we're trying to solve. For example, in the 2x2 grids which we studied previously, there are 4 pixels and therefore 4 inputs, 1 for each pixel. In a 10x10 grid, there would be 100 inputs. If, on the other hand, we were monitoring the health of a jet engine, which had 20 sensors instrumenting it, then there would be 20 inputs, 1 for each sensor. And if we were monitoring, for example, heart rate, blood pressure, and blood sugar level in a human being, then there would be 3 inputs, 1 for the heart rate, 1 for the blood pressure, and 1 for the blood sugar level. For reasons which will be explained in later videos, the number of outputs is the same as the number of patterns we want to recognize. So, for example, if we wanted to recognize the 26 letters of the alphabet, we'd have 26 outputs. If we wanted to recognize 5 faults in a machine, then we would have 5 outputs. The outputs are coded as shown in the diagram on the screen, with a 1 at each position of the output corresponding to each different pattern. This only leaves the number of neurons in the hidden layer to choose. Unfortunately, there is no formula for deciding this. It depends on the number of patterns which you want to recognize and their complexity. Experience is the only real guide. As an example, a network designed to recognize the 26 letters of the alphabet will often work quite well with between 8 and 16 hidden layer neurons. And so there's a fair bit of latitude in the number that you choose, but you simply have to try out a few different examples in order to find one that works well. We'll return to discuss the size of networks in later videos.